functions, right? We are going to be doing what are called inverse functions today, which is funny. We did inverse, sine, cosine, and tangent yesterday in geometry with all that stuff. Remember what the inverse sine looked like? It was that sine to the negative first power, cosine to the negative first power is what it looks like. Now move into algebra 2. The inverse looks the same. It's taking that f with that -1 superscript is how you represent an inverse, okay? And when we find an inverse function, all you really are doing is you're swapping your x and your y values, okay? So just try to keep that in mind. If you can always go back to that, these are not terribly difficult problems. The inverse will always swap the x and the y values, okay? Here's what an inverse does. I'm going to draw you a little picture. We're going to go back to elementary school for a minute. I think I mentioned this the other day. The function machine. Remember the function machine? I'm going to draw my function machines a little different today, but they're all, function machines still. Okay, so I have these two function machines. You don't need to write this down. Just hear me. If I have some function, g of x, and I have some other function, f of x, okay? Let's say g of x is the function x plus 2. If I put a 4 into my function machine, what does my function machine spit out? 6, right? 4 plus 2 is 6, okay? An inverse undoes, essentially, what we already did. So the inverse, excuse me, we're going to say this function is x minus 2 because now when I put that 6 in, 6 minus 2 is 4. So we get back what we started with, right? An inverse just kind of undoes what we did, if that makes sense, right? Kind of like opposites a little bit, inverses. Jada, did you have a question? I am. Thank you, though. I appreciate that. Okay, so inverse notation, like I said, looks like this. So it's the inverse that it's, goodness, f inverse of x is how we're going to say it. F inverse of x, okay? F inverse of x. Okay, so let's think back a little bit to just some of the general ideas of functions. We did this, gosh, what chapter was that? Where we did all the domain and range stuff. I don't remember off the top of my head. But for a function, right, in the original function that we're given, the domain was always which values? The x values, okay? So we're just going to say we're talking about the original function because there's going to be a new function. The domain was the x values. The range was what? The y values, yeah. So in a regular old function, domain is the x values, range is the y values. And we did something called the vertical line test. Do you remember that? VLT, vertical line test, to see if something was a function. Do you remember how the vertical line test works? Good morning, Meg. Thank you. Miles, this is for you if you want to come grab it. If I gave you something that looked like this, and I said, try the vertical line test on it, what am I looking for? Yeah.
Like put your pencil or something like upwards.
Mm-hmm.
If 2 points are like hit on that same line, then it's not a function.
And it's not a function, right? So if I can hit 2 points when I do any vertical line, it is not a function. So this is a function, right? Because I don't hit any 2 points at the same time. Okay. Vertical line test. Basically, your x values don't repeat. Okay? Okay, so that's what we already know about functions. Inverses, jump to the other side, the domain and the range swap, right? We said we're going to swap our x and y values. So now your domain is your y values and your range is your x values, okay? And instead, we have something called the horizontal line test. So everything kind of gets flipped upside down. The horizontal line test has to be done, notice I put this in red because it's very important, has to be done to the original function, not the inverse function that we come up with, okay? The function we start with, so go back over to here, right? If my function looks like this, and I do the horizontal line test, which is the same idea. If I draw a horizontal line and I hit in 2 places anywhere, then my inverse is not a function. Okay, so even though the original was a function, the inverse of this one, because it doesn't pass the horizontal line test, the inverse is not a function. Okay? And this will make more sense as I show you actual problems of it. But just keep in mind, you're always doing the horizontal line test to the original function, not the inverse function, not the new one, the one you started with. Check the horizontal line test. Okay, so let's take a look at this. Example 1. It says, is the inverse of the function given, is the inverse of it going to be a function? Okay, so this is the original function, this graph. Is the original a function? Yes, okay. Then if we were to say, well, let's find the inverse of that graph, would that be a function? Does it pass the horizontal line test? No, right? We hit in 2 places all over the place. So is the inverse of this function a function? The answer is no. Okay, that one will not be because it doesn't pass the horizontal line test. Does that make sense?
Yeah.
Okay. Keep going here. This one, okay? The function is y equals 2x plus 4, and we gave you a graph of it. That's what y equals 2x plus 4 would look like. First of all, is that a function? That's a function, right? I could do the vertical line test, and I would not hit any 2 points at the same time. Okay. Is the inverse, which is what we're asking, is the inverse of this a function? Yes, right? I can do the horizontal line test, and I will not hit any 2 points at the same time. So this would be, yes, the inverse is a function. Okay? Okay. Show me how good you are here. Can anyone tell me what the graph of that equation, y equals the absolute value of x plus 3 minus 4, what that looks like? I got all kinds of, good job, you guys. It's a V, right? Anyone want to give me a more specific V? You don't need to, but I'm just curious if you remember what happens with it. It's not upside down. It's right side up. Where did it move?
Down 4.
Good
left,
job.
3, 4.
Oh, he even did the opposite part right, you guys. Down 4, left 3, right? 1, 2, 3, 4. 1, 2, 3. Your vertex would be here. It looks something like that, okay? Don't worry if you didn't fully remember that. That's just me wanting to see what you got still. So the question is the inverse a function? No, why not? It does not pass the horizontal line test. Is this a function? The original is a function, right? Because it passes the vertical line test. But the inverse, which is what they're asking us about, is not a function. Doesn't pass the horizontal line test. Okay? Questions on that? Okay. Example 2 here. We are going to find the inverse, and we're going to graph it. Okay? First of all, is this first set of information a function?
Yeah.
Why?
Because none of the, like, if you were to say, like, what is -1, it goes to 1. So it's fine.
Look further down the chart, though. There's 2 1s, right? Can you have repeat x's for a function? No. So the original is not a function, okay? We're going to find the inverse. Now, how did I tell you we will find an inverse? Swap. Okay, so here's what you're going to do. When they give you a chart like this, it's super easy. You have your x's and your y's, okay? I wouldn't replace where they are because you want to still think in terms of this is my x, this is my y, right? All you're going to do is swap them. So it's going to be 1, -1. And then your second one is going to be 2, 0. And then 3, 1. And then 4, 1. Okay? Now, we're going to graph both of them because I want you to see what I want you to see. So for this first set of points, I'm going to do this one in orange. Okay? You don't have to, but just so you know which one I'm doing. So we've got -1, 1. You know what? I'm going to move this a little bit just so we're a little closer. There we go. So the point -1, 1, 0, 2, 1, 3, and 1, 4, right? So that's our original function. It does not pass the vertical line test. It's not a function. Our second one, I'm going to do this one we'll do this one in blue. Okay, when we plot those points, 1, -1, 2, 0, 3, 1, and 4, 1. Okay, so this one's the inverse. This is the original. Okay, it says find the inverse and graph. So technically at this point, you're done. Okay, you found the inverse, you graphed it. Do you see anything in those 2 graphs? They reflect, okay? An inverse always reflects over this line. Do you remember the line y equals x? 0, 0, 1, 1, 2, 2, 3, 3, where x and y always equal each other is the line y equals x. This diagonal line right here is where every inverse will reflect, okay? The line y equals x, which makes sense, right? We're swapping our y and our x, so it makes sense that that's the point at which they would flip over. But just keep that in mind. It's just a helpful thing to be able to check how are things looking. Does this make sense? So every inverse will reflect over that line, okay? Questions on that? Okay, let's look at this next one. This one's a little bit different because we don't have a chart this time. We have an equation instead. What we're going to do is we're still going to swap our x's and y's, and then we're going to resolve for our equation, okay? So swap your x and your y first. So we're going to take x and y, and we're just going to flip where they are in the equation. So I'm going to write this as x equals 3y plus 2, okay? Swap your x and y. That's the first step. How do I then, step 2, solve that for y? What would your first step be to solve that for y? Subtract 2, right? So if I take away 2 and take away 2, I have x minus 2 equals 3y. And then last step to solve for y is divide by 3 and divide by 3. So I get y equals x minus 2 divided by 3. This is my inverse. Okay, that's the equation of my inverse. Okay, then what I would do, and I will show you on your graph, on your calculator, how you can do this also, but you're going to graph the original equation, okay? And you know how to do that. You have options. You could either plug in numbers. So I could plug in a 0 and see what I get for y, then plug in a 1 and see what I get for y, right? So if we want to do it that way, just think t-chart, x and y. If I plug in a 0, 3 times 0 is 0 plus 2 is 2, right? If I plug in a 1 for x, 3 times 1 is 3 plus 2 is 5, okay? So I know those are going to be 2 points on my original graph, okay? My original graph looks like this, 0, 2, 1, 1, 2, 3, 4, 5. What is the shape of this graph, by the way? Y equals 3x plus 2. It's a line, right? It's a linear function. So you only need 2 points, and you can draw the line in. I plugged into the original function, right? So I'm saying this is my original function. This is the OG, right? My inverse then, my inverse would be to swap those points. So my x and my y for my inverse are going to be 2, 0 and 5, 1. Okay, so 2, 0, 1, 2, 0, 5, 1, 2, 3, 4, 5, 1 would be right here. Okay, so this is my inverse. Orange is my original, purple's my inverse. Okay, notice the line they reflect over makes sense, right? It's right there, which you don't have to draw that in, but that's what it looks like. Okay, if you want to see these on a calculator, like so you can check your answers, stuff like that, or if, you know, to get just your mind wrapped around it a little bit, I'm going to show you how you could do that. It's very simple. God bless you. My calculator will open. There we go. Okay, so we have 2 equations. Our first equation, so you're just going to go to y equals, and you'll be here. Okay, if there's stuff there, just clear it out. And again, you don't have to do it this way. Okay, this is just so you can get a look at it. Make sure you're getting the right stuff. 3x plus 2 is the one equation. So 3x plus 2. Okay, that's your one equation. Your other equation is x minus 2 divided by 3. So you got to put parentheses around the x minus 2. X minus 2, and then divided by 3. Okay, so those are my 2 equations. Now, if you go second table, this is all your points. So your first your first y1 equation has the point 0, 2, 1, 5, 2, 8. Your second one has the points 2, 0. Go down to here, 5, 1, right? Those are the points we already found. Right here, the graph button. So you have to go second, and then graph is your table. So that'll give you all the points for those functions, okay? And then if you, instead of hitting table, now if you just hit graph, it'll show you what that graph looks like, okay? So you can see it on the calculator. You can do it the way I showed you by hand up here. Either way is fine, as long as you're getting to that point, okay? Okay, let me pull this back up. Let's talk domain and range for a minute. Okay, so the original function, right? This is for the original. What's the domain? Remember, the original was that y equals 3x plus 2. What's the domain of that? What are you allowed to plug in for x right now? Could you plug in 1,000,000? Could you plug in -42? Could you plug in -1,000? Could you plug in 0? Are any of those off limits? No, right? You can plug in any of them. So your domain is what? All real numbers. Yes, your domain is all real numbers. When you plug those numbers in, what can you get for y here? Think about your graph. It keeps going forever this way. It keeps going forever this way. So your range is all real numbers also, okay? Here's the beautiful thing about inverse, domain, and range. All you do is swap them. So your range for the original is your domain for the new one, for the inverse, and your domain for the original is your range for the inverse. Okay, so just like you swapped your x and your y, you swap your domain and your range, your x's and your y's, right? Okay, any questions on that? They're so quiet. Just talk, like be loud. I don't even care. Say something. It's painful. I want to talk. Okay, letter C. Here we go. We are going to find the inverse and graph it again. What do you do? Swap x and y. Now, don't let this freak you out. You're like, oh, there is no y. F of x and y are really the same thing, right? So this is y equals x squared plus 3. So we're going to rewrite it as x equals y squared plus 3. Okay? Then we're going to solve for y. So the way we do that is we subtract 3. So it's x minus 3 will equal your y squared. And then we have to square root it because we want to solve for y. So square root both sides and you get y equals the square root of x minus 3. Okay, so that's our inverse. But when, oh, I forgot a part. What do you have to do when you square root something on both sides? Plus or minus, yes. Don't forget that. It's really easy to forget that. I just did. Plus or minus, okay? Y equals plus or minus the square root of x minus 3. Okay, so the way that you can write that so that you remember that that's your inverse, remember the notation for it? Inverse of f of x, f inverse of x, is plus or minus the square root of x minus 3. Okay, I'm not picky. If you write it like this, I don't take off points for that. But this is helpful for you just to remember, like, this one's my inverse, okay? Okay, so when we do this now, we're going to try to figure out what points we have and swap them so that we can graph both things. But now here's the deal. What is this? Can anyone tell me what that looks like? X squared plus 3. What's the graph of the original going to look like? A parabola, right. So keep that in mind, right? This is a parabola that has shifted where? Up 3, okay? So if I were you, I would, if I'm making the t-chart, okay, I would plug in a 0 because all it has done is shift up. It hasn't shifted left or right. So if I plug in 0, I get 0, 3. And then I would plug in a -1 and a +1 to see where we went, okay? So if I plug in a -1, -1 squared is 1, plus 3 is 4. If I plug in a +1, 1 plus 3 is 4. Okay, so my original graph is going to be 0, 3, 1, 2, 3, 1, 4, and -1, 4. All right, that's my original function. Okay. To find the inverse, have you ever tried to graph something like this before? It's ugly, right? Don't. Just swap your x's and your y's. Here's your x's and y's for the inverse. Swap them. So 3, 0, 4, -1, and 4, 1. 3, 0, 4, -1, 4, 1. Your graph looks like this, right? It's reflected over that line. Does that make sense? So don't let this freak you out. Like, I don't know how to graph that. Don't worry about graphing that. Graph the inverse of your original function, right? Swap your x's and your y's. Okay, so now we're going to look at what of the original, what's the domain and what's the range. And your graph is really helpful for this. What is the domain? What could your x values be for this graph? What can you plug in? All real numbers. You can plug in any value for x for that. So don't even think about your second graph right now. What's your inverse range going to be? All real numbers. These have to be the same, okay? So this is going to be all real numbers, which if you think about it, your y values are going to keep going up and down all the way. Okay, your range. What can your y values be for this graph? Greater than or equal to 3. Y has to be greater than or equal to 3. Now here's the one place you have to be a little bit careful. The inverse domain, okay, has to be that range, but domains are x's, right? So instead of y is greater than or equal to 3, it's the x value that's going to be greater than or equal to 3. And if you look over here, we're at 3. It's got to be greater than or equal to 3 on your x-axis, okay? Does that make sense? A little bit, hopefully. A lot of it. Okay. Last one, and this one's the toughest one just because of the nature of the original function, but we'll talk through it and it'll be great. So you have y equals the square root of x plus 1, okay? What's the first thing you do?
Swap x and y.
Swap x and y. So we're going to swap them. We're going to say x equals the square root of y plus 1. Okay, now we're trying to solve for y. What do I have to do first here? Someone say it. I heard this, which would be right. Square both sides, right? To get that radical out of there. We're going to square and we're going to square. So x squared equals y plus 1. Okay. Now to solve that, we're going to move that 1 over because we're trying to solve for y. So y equals x squared minus 1. Okay, now I'm going to show you on the calculator. This one's just so much nicer if you just do it on the calculator, and I'll show you why in just a second here. Let me pull it up here. Okay, clear out your y1, clear out your y2. And what I want you to do first is I just want you to put the graph in for the original function real fast. So the square root of, so second square root, and then x plus 1. Okay, just hit graph real quick. Just take a look at what that looks like. That's the graph of the square root of x plus 1. The inverse, where we have y equals x squared minus 1. I'm going to put it in here so you can see which one I'm talking about. Y equals x squared minus 1. What does this graph look like? What shape is it? It's a parabola. That's an issue, right? Because our original was not a parabola. So the inverse of it can't be a parabola. What happens is the inverse is going to appear to be a parabola, but you can't graph a parabola because it's not actually the inverse. You have to reflect the original graph, right? So if I graph this right now, I get a parabola, but that doesn't make sense because that's not the reflection of the blue line. Only half of that is the reflection of the blue line, right? So I just want you to see that. It's going to be a little bit of like, wait a minute, that's not, I can't graph that whole thing. But what you can do is ditch your second one here. That's what I'm going to do anyway. Clear that out. Okay, now go second table and it will give you your points for you. If you want, you're welcome to plug things in, but you have to really think about what numbers are gonna make sense when I have to square root something, and it just is hard. So if you just go second, and then the graph button to get your table, look how nice that is. It tells you exactly which numbers are nice numbers. Basically what it's saying, I'm gonna jump away from this and back to my notes. If you need to see this again, let me know. What you're doing here is you're saying my chart, X and Y, would be, remember the numbers were 0, 1 is one of them. There's a 3, 2. Okay, and you can actually, oh, all this jumping back and forth. I'm really sorry, but I want you to see this. You can also notice there's more up here, okay? Error means there's nothing there. It's not a point, but there was a -1, 0 there. So you can use -1, 0 also. So you can always go up in your table if you need to see more of it, which I would use on this one because that's your starting point, and you always want to have a good starting point. So I would do, what was it, -1, 0 also. I would use those 3 as my 3 points that I'm going to work with. Okay, that means my inverse then is what 3 points? 1, 0, 2, 3, and 0, -1. We're just swapping, right? We're just switching our X's and our Y's. Okay, so let's graph those. Your starting one is 0, 1, 3, 2, and -1, 0. Okay, so this is what the graph looked like. And we graphed it, right? So then you know, like, okay, I saw it on my calculator, that's right, this is what I want, okay? The inverse then is gonna be 1, 0, 2, 3, and 0, -1. So that's just this half of the parabola that we were seeing is our graph. All right, so let's talk domain and range. For the first one, okay, that was the pink graph. This one is our pink graph. This one is our orange graph. So for the pink graph, what's your domain? What do your X values have to be? Less than, greater than, all real numbers? What could you get for X?
Greater than 0, or greater than equal to 0.
It's not 0. Look where your X starts on the pink graph. -1. X has to be greater than or equal to -1, right? Here's our starting point at -1, and X kept going forever and ever and ever to the right of that, okay? So X has to be greater than or equal to -1. What about the range? What doesn't it drop below? Your Y value never goes below 0. So your range is Y has to be greater than or equal to 0, okay? Now you don't have to worry about it for the inverse. You swap them. So this is gonna go here, but make it X. X is gonna be greater than or equal to 0. This one's gonna go here, but make it Y. Y is gonna be greater than or equal to -1. Questions on that? Right.